One of the projects over the last year was focused on human-robot team training. And what we tried to do was take insights about how people work effectively in teams. So how pilots learn to work together in a cockpit, how medical teams learn to work together, how military tactical teams train. And there's a large body of work in this 30+ years on effective human team training. And we compared that to how it is we're training robots today. So in the laboratory, when we train a robot, one of the ways we train them is through demonstration. So we show the robot what they should do very explicitly. Or we train them through interactive rewards. So the robot does something and we say that was good. The robot does something, we say that was not good. And the robot kind of learns through that reinforcement process. But what we observe is that both these mechanisms we use to train robots today actually look very different than the proven effective human team training techniques. In fact, some of these techniques we use to train robots today are documented as among the most inefficient ways that humans will learn to work together. So what we did was an experiment where we took state-of-the-art algorithms in reinforcement learning and we modified them just a little bit so that instead of taking the input as positive and negative reward, the robot took its input by switching roles with the person in a virtual environment. So the person would do the robot's role and the robot would do the person's role. And this is highly effective in human teams. People like doing this. They like cross-training, it's called, because if someone is out sick on the factory floor or in your team, then someone else usually knows how to do their job. So it has a practical benefit. But there's another benefit as well. So there's empirical evidence that by actually doing someone else's job, you take that information about how your partner needs to do their job effectively back with you when you go back to do your own job. And so people are better able to anticipate what their partners will need, and the outcome is more effective team performance, better response to errors and disturbances as a team. We were interested in exploring whether cross-training in a human-robot team results in these better outcomes at execution. And one question we could look at is, does the robot learn better from this? But the algorithm's similar to the prior state of the art. So the other aspect we can look at is, by training through cross-training, are we better supporting the human's learning? Is the human learning more effectively how to actually work with the robot? And so we conducted experiments. We compared half of our human-robot teams, which learned to work together using the prior state-of-the-art reinforcement learning algorithm. And the other half of the teams worked together in a virtual environment to switch roles. And the outcomes were really surprising and exciting for us. We saw improvements after cross-training in objective measures of team performance. We saw statistically significant increases in concurrent motion between the person and robot. We saw statistically significant reductions in the person's idle time after cross-training. And we also saw subjective benefits. So people reported that they agreed more strongly, that they trusted the robot, and that the robot performed according to their preference. So, this is an initial study with a relatively simple task, but even in this simple task we did see statistically significant benefits, which opens up an opportunity for us to explore a number of other different human team training techniques and how we can translate those to work in a human-robot team.